Hey kiddos, so this video will go over the notes on matter. We've been talking about matter for a while now. We've done some readings on it and we've measured matter as well. So these notes are to provide you with a study guide essentially that you can look back to and refresh your memory on any of the terms that you might end up being quizzed on. So we know that matter is anything that takes up space and has mass. That means everything around you, whether it's the computer that you're watching this on, your paper and pencil, or the air in front of you. We know that when we're moving in a car and we stick our hand out the window, we can feel the air blow that hand back. On a breezy day, we feel that wind go past us. We know that there is air there, which therefore means that it has matter, or it is made up of matter, and it therefore has mass. We're going to be exploring a lot of different properties of matter. So physical properties are anything that can be observed or measured in any way. Those that are characteristic physical properties are always the same for a substance. So how big or how heavy or what shape it's in is not a characteristic physical property, because those things can change. I can take a piece of metal and I can shape it differently. I can chop it in half and now it's smaller and it weighs less. So the underlying substance remains the same even if I change these. They're definitely physical properties, but they're not characteristic properties. Characteristic physical properties would be like density. The density of a pure substance will always be the same, and it will, no matter what I do to it, except for changing its state, stay as the same density. Its boiling point and melting point. It has a specific temperature at which it boils and which it melts, right? When we think of water, it boils at 100 degrees Celsius and freezes at 0 degrees. Whether or not it can dissolve, right? Break apart into small little pieces when mixed usually with water. Color, viscosity. We talked about viscosity, that word, once before. So characteristic physical properties are those that define the matter itself. So if we test some unknown liquid and we find that it boils at exactly 100 degrees Celsius, we're pretty sure that it's going to be water because water has a specific boiling point. Mass is when we're measuring the amount of matter. So it's telling us whether or not it's heavy or light. It's how much of that object is there. Everything has mass because everything is made up of matter. The units that we're going to be using are grams and kilograms, and we're going to use a triple beam balance most of the time, though occasionally we'll use a scale. Volume is the amount of 3D space, so that we're asking how big or small an object is, while with mass up here, we're asking if it is heavy or if it is light. Volume will be centimeters cubed because we're taking length times width times height. It's three-dimensional, or we're going to use milliliters or liters. We've talked about and we've used the three different methods. The spillover is the first one, and it's the worst one. We place an object into a spillover cup and we measure how much water spills out. This is only used for big and irregularly shaped objects. It's a last resort. Displacement is quite accurate. We place water into a graduated cylinder. We then add the object into that graduated cylinder and see how much the water goes up. This is going to be for, again, irregularly shaped objects and small ones, right? If they can fit in a graduated cylinder, it's way better than having to do the spillover method. Length, width, height is what we do for cubes and rectangles and the sort. There are obviously equations for other regularly shaped objects like a triangle or I guess it would be a pyramid if it was three-dimensional, or a sphere, right? There are different equations to use, but length, width, height is the most common one and used when where you've got a regularly shaped object that is easily measurable. Distance we know to be just the length or distance between two objects. We're using centimeters, meters, kilometers, because it's all based on a factor of 10 with the metric system. Temperature we've discussed. It's how fast atoms move. It's measured in Celsius. So temperature is not really a measure of whether or not something is hot or cold. It's a measurement of whether there is fast molecular motion or slow molecular motion. Things that are hot usually feel that way because the molecules are moving faster, right? We've given it some type of energy, whether it's thermal energy, energy from microwaves, right? Using your microwave. But adding that energy makes the molecules move faster, and therefore we come into contact with them more, and therefore they feel hot. An increase in temperature can cause a change in state. We're going to come back to that on the next page. Density is how tightly packed molecules are. So if we're looking at these two images here, right, I guess these are glasses of water, this one here is less tightly packed with whatever this red molecule is than this one, which means that in image 1 right here, there's more space between the red molecules. They are loosely packed, whereas over here, they're more crammed in. There are more molecules per cup, more red molecules per cup or per cylinder. So we calculate it by taking the mass of an object and dividing it by the volume. We take how heavy it is and divide it by how big it is. That's going to give us actually 2 units when we calculate it, because it'll be the mass in grams divided by the volume in milliliters, or potentially centimeters cubed. Another example, we're looking at these yellow molecules, which are all slammed together really, really close. We can't even see any space between those molecules because of how close they are. Over here, we can see lots of space, right? You can see between these molecules, which means they're not as tightly packed. They're not as compacted or as thickly packed or anything like that. So that would be less dense because there are fewer molecules in the same amount of space as over here. If you can squish them in together, it means there are more molecules in less space. That would make it more dense. You've studied states of matter probably every year since 3rd grade, right? As we've been talking about how water can become a gas or a solid. And technically, every pure substance can do that as well. We can take aluminum and make it into liquid aluminum. You just have to get it super duper hot. And theoretically, you could make it into a gas, though the temperature at which that would happen would be millions and millions of degrees and very unlikely. So as something goes from a solid to a liquid, that's called melting. We do that by adding energy. We add usually thermal energy, and that then changes it from a solid to a liquid. We're most familiar with this process happening with water because we're used to our ice melting and then evaporating, right, as it becomes a gas. But it can happen to any pure substance. As this happens, as it moves from a solid to a liquid to a gas, things change in density. The reason for that is because as we're adding thermal energy, those molecules get energized, which means they can start to move around. And a solid, where it's only slightly vibrating, so little that we can't even see it, a liquid starts to slosh and move around slowly, but then as it becomes a gas, those molecules can move freely. They can bounce all over the place. That's because they have so much energy that they can bounce essentially wherever the wind takes them. And with all that energy that they have been given, right, we see right here, it says increasing energy, they can spread out and fill up any container, right? They can fill up any room. So if there's something really good cooking down in your kitchen, you can smell it all the way upstairs because the gases, not natural gas or propane, hopefully, but the actual gases from the food being let out are wafting upstairs, and you can smell that chicken cooking or that bacon cooking down on the stove, right? And that's because certain things have turned into a gas and therefore have enough energy to bounce around and spread out throughout your house. If it's only a liquid, you sometimes can smell it, right? You might be able to, but liquids stay in their container, right? That would be, and they can take the shape of that container because they have more energy than a solid and are a little bit less dense than that solid. The one caveat to that is that we know that ice is really weird, and when water turns into a solid, when it becomes ice, it actually, the molecules spread out more than the liquid state, which is why ice floats. It's one of the only known molecules to do that. But in general, as things move from solid to liquid to gas, they become less dense as they become more energized, which is why things spread out.